Welcome to another segment of my physics lesson as we continue under current electricity. So we are going to look at electrical energy, but before we look at electrical energy, let's give you a few concepts that we did talk about under what we called as spin power. What exactly is power? Well, we define power as simply the rate at which work is done. So we can simply say that power is the rate at which work is done, and that is what we simply call spin power. Now remember, of course, that work is simply a form of energy, so you also need to remember that work is a form of energy. Therefore, what's the formula that we are going to be using for power? Remember, we simply say that power in this case will be equal to the work done. So we can simply say the work done divided by the time that has been taken. But remember, work is a form of energy. So we are simply saying that power is equal to the work done divided by the time. And what is the SI unit for power? If you still remember, the SI unit for power is what we simply call as being the watt. And this is represented by capital letter W. But of course, if you remember, because work is measured in joules and time is measured in seconds, when you combine that, that will give you joule per second. So the relationship between the watt and the joule per second is that 1 watt is equal to 1 joule per second. So remember, you can also use joule per second. That is very fine to represent what we are calling as being a watt. Now let's try to misbehave with this formula, because we are saying that work is a form of energy, and therefore where there's work, I can simply put up energy, because work is simply a form of energy. We can therefore say that power is equal to energy divided by time. But we know something, that energy is equal to voltage multiplied by charge, if you remember from our previous discussion. So therefore, where there's energy, I can replace with voltage and charge. So it is going to be power is equal to, in this case, it is going to be voltage times charge divided by time. But we also know something about this. We know that charge is equal to current multiplied by time. So therefore, where there's charge, I can replace with IT. So it will be power is equal to voltage IT divided by T. Do you notice something that can happen there? Definitely, you see the T and the T there can cancel. Therefore, it will give you power is equal to voltage times current. Let's say this is another important expression that you can use in order for you to calculate what we are calling as being power. So power can be given simply by the voltage multiplied by the current. So if you know the voltage and the current, it is possible for you to calculate what we are calling as being power. All right, we can continue and look at this expression. Now suppose I replace this expression with Ohm's law. I know in this case that we have established that power is equal to voltage times current. But according to Ohm's law, we know that voltage is equal to current times resistor, meaning that where there's voltage, you can replace, IR, current times resistor. So it will give us power is equal to IR, representing the voltage, times I. So power is equal to I times I will give you I squared multiplied by resistor. Let me say this is a second important equation that you need to know. If you want to calculate power, if you know the current and the resistor, it is possible again to calculate the power. Well, let's go back again to that, expression, power is equal to voltage times current. Suppose using Ohm's law, I make I the subject of the formula. Well, if I make I the subject of the formula, then we can also say that current is equal to voltage divided, in this case, by resistance. So replacing where there's current, we replace with VR. To give us power is equal to voltage multiplied by V divided by R. Remember, this is over 1v times v will give you v squared over r. Let's say that this is the third expression that you can use in order to calculate power. So you can see that there are a lot of expressions that you can use in order for you to calculate what we are calling as being, power. So it is possible that you can calculate power. Now let's take it a bit further and look at that formula again, what we are simply calling as being electrical energy. So let me just try to clean up this section and introduce you to another world. So we are simply saying that electrical energy is equal to voltage multiplied by charge. But what do we know? We know, of course, that charge is equal to IT. So I can replace where there's charge with IT. So electrical energy will be equal to voltage current times time. So you can use again that expression if you want to calculate your electrical energy. So it is possible. But of course, using this expression, electrical energy is voltage current times time. We also know from our previous discussion, I said that power is equal to voltage times what? Times current. And therefore, where there's a voltage and current, I can simply replace what I'm calling as being, power. So E can be equal to, power. This whole expression will be represented by power multiplied by time. So it is possible you can have such an equation again to calculate your electrical energy. And this is one of the famous formulas that we are going to be using in a short while in our discussion as we calculate electrical energy. So electrical energy is equal to power multiplied by time. Well, let's keep on misbehaving again. I'll get the expression again. I'll get the expression again there, which we are saying that electrical energy is VIT. Let's try to use what we are calling as being Ohm's law. What do we know? According to Ohm's law, we know that voltage is current times resistance. Remember, I'm just playing with the formulas here. So where there's voltage, can I replace with current and resistance? So it is going to be equal to IR, that is representing the voltage, then multiplied by IT. So electrical resistance is equal to I times I will give me I squared multiplied by resistor multiplied by the time. So this is another third equation that you can use to calculate what we are calling as being electrical resistance. So it is possible you can also use such an expression to calculate electrical resistance. But again, we can still use the same expression. E is equal to VIT, and this time we try to make I the subject of the formula using Ohm's law, voltage times resistance using Ohm's law. Then we replace where there's I, we can put up that. So E will be equal to V multiplied by V over R multiplied by T. So E will be this times that will give you V squared over R multiplied by T. So you can have that expression, which we can simply write and say E is equal to V squared T over, R. So you can also use that one, to calculate your electrical energy. So sometimes they ask you which formula can you use to calculate electrical energy. Remember, E can be V times Q. It can be that expression, or this expression that we have come back to. So let's go back to this one there as I teach you now about what we are calling as being electrical energy. Now, how do you calculate the cost of electrical energy in a home? Well, it's very simple. We can put up the heading there and simply say electrical energy. So electrical energy, what exactly is this electrical energy? Well, I can simply say that electrical energy is a form of energy resulting from the flow of charged particles such as electrons through a conductor. So that is what I can simply say. So I can simply say electrical energy is a form of energy resulting from the flow of charged resulting from the flow of charged particles, such as electrons. So electrons in a conductor. So that is what you can simply call as being electrical energy. Or in simple terms, as I can call it, electrical energy, I can simply say, maybe let's say electrical energy E is the energy, let me just say is the energy, sorry, we are simply saying is the energy, supplied, the energy supplied in T seconds. So that's what I can say, the energy supplied in T seconds. So the formula that we use, we are going to say that electrical energy is equal to power multiplied by time. So I can say that E is equal to power multiplied by time. So we can use this as the formula for calculating electrical energy. And please take note of this. You are going to be using it in a short while. So what is the SI unit for energy? Remember, energy is simply measured in joule. So we are going to be using the joule. So take note of that. Now, when can this be in joule? Well, for your unit to be in joule, then electrical energy is equal to power multiplied by time. So for energy to be in joule, it simply means that your power is supposed to be in watts and your time is supposed to be in seconds. So when your power is in watt and your time is in second, then it simply means you're expressing in the unit we are calling the joule. In simple terms, 1 joule is the same as 1 watt second. Remember, this is what you need to remember. So it is the same as 1 watt second in this expression that we are having there. So very important. Okay, let's get it back and give you the larger unit for electrical energy. What is the larger unit for electrical energy? Well, the larger unit for electrical energy, so maybe I can talk about the larger unit for electrical energy is the kilowatt hour. So we use the kilowatt hour. So we can use kW an hour. Obviously, you have heard of the kilowatt, and sometimes we call that one as being a unit. So we call that one as being a unit. So that's what we call. So a kilowatt is sometimes referred to as being units. For example, when you go to buy units, you say, no, they have given you 100 units. You mean they have given you 100 kilowatt hour. So that's what we mean. It's just a larger unit for electrical energy. So therefore, if you want to calculate your electrical energy in kilowatt, power multiplied by time, if you want your energy to be in kilowatt hour, it simply means your power is supposed to be in kilowatt and your time is supposed to be in hours. So when that is in kilowatt, your power is in kilowatt, your time is in hours, that will give you kilowatt hour. So that is what you need to remember to use that. Now, let me just give you a tip. What exactly is a kilowatt? Well, when we talk about 1 kilowatt hour, when we talk about 1 kilowatt hour, well, 1 kilowatt hour is the energy, we can say is the energy consumed. So it's the energy consumed by a 1 kilowatt rated appliance for 1 hour. So the energy consumed by a 1 kilowatt that rated appliance for just an hour, that is what we simply call as being a kilowatt. Now, sometimes you are going to be converting between watt and kilowatt. You need to remember that 1 kilowatt is equal to 1000 watts. So this unit conversion will help you to make some few conversion. What do I mean? Well, for example, we can tell you to convert from watt to kilowatt. You don't need to waste time when you're doing that. Let me just show you how you can do that. Let me show you how you can do that using that conversion. For example, if I tell you to convert 500 watts and I tell you to convert to kilowatt, remember 1 kilowatt is equal to 1000 watts. So you can just say 500 watts How many kilowatt will that give me? Cross multiply. This times that is a 1000. X, which is equal to this times that is a 500. You are going to divide by 1000. What you do this side, you do it the other side. So your X will give you a 0.5 kilowatt. So in simple terms, when you're moving from smaller to bigger, you don't need to waste time. If I've given you a watt and I tell you to convert to kilowatt, just get the 200 and divide that by 1000, which will give you a 0.2 kilowatt. Well, thank you so much for watching my video. See you in my next video as I look at some practice questions that you're going to look at.